All right, when we get to this next set, this is really the same set of instructions as in the first several questions. They're written differently, but we are still rewriting these in factored form. So this is the same as if I said this is the area of a rectangle, write it in a form where we can see the dimensions. So the first thing that I'm noticing is that in these problems, our A value is no longer 1. So we have to be careful. That makes it harder when A is not 1. And the first thing we always want to check is, can I factor out a GCF? Because if we can, that's going to make everything easier. So in number 11, I notice that 2x squared, negative 2x, and negative 24 are all divisible by 2. So before I go to my area model, I'm going to think of this as 2 times 1x squared minus 1x minus 12. And so we could really think of having two area models that are two rectangles that are the same. So it's like I have two rectangles that are both x squared minus x minus 12. And you could probably get away with just drawing one of these. So I've got x squared minus 12 and x squared minus 12. And so again, I want to think what multiplies to negative 12x squared that has a sum of negative 1. All right, so if I think of my factors of negative 12, well, I know first of all that since these numbers are negative, that I have to have a negative and a positive when I factor. So if I think about numbers that multiply to 12, I know I've got like 1 and 12, 2 and 6, 3 and 4. But for them to add up to a negative number, one of the numbers has to be negative, and it would have to be the greater of the two numbers. So now I just say, which of these has a sum of negative 1? Well, that's going to be 3 and negative 4. So I have a negative 4x and a 3x in both my rectangles. All right, so now when we get to the actual factoring, again, I want to pull out my greatest common factor. So like of my top row, that's an x. I know to make x squared, I need an x here. And then if I pulled out an x from negative 4x, I need a negative 4 up top. In this column, I need a plus 3. And if I double check, negative 4 times positive 3 is negative 12. So we should get the same for both of our rectangles. So in factored form, it's like I have two rectangles and their dimensions are x minus 4 times x plus 3. All right, so when we can pull out a GCF, our GCF is right here. So we really only have to worry about factoring this part. But unfortunately, we can't always pull out a GCF. So in number 12, notice that 9x is not divisible by 2. So I'm going to have to do this problem differently. And I'm going to have to make one rectangle that has a 2x squared here, a negative 10 here. And remember, I'm looking for two numbers that multiply to negative 20x squared. So it's not just my c value, but I have to multiply the c value and the a value. So 2 times negative 10, and 9 is what we call our b value. All right, so if I think about factors of negative 20, and if you can come up with it in your head, you don't have to list them all, it just helps me to list them out. Well, again, I know this is a negative number, or a negative product really, when I multiply. So I'm going to need a negative and a positive. Doesn't matter where you put the negative, where you put the positive in the diagram. Let's see, and we need a sum of positive 9. So we need numbers that multiply to a times c and have a sum of b. All right, so our factors, we could think negative 1 and 20, but that has a sum of 19. I could think negative 2 and 10, but that has a sum of 8. Or I could think, let's see. let's see, -2 and 10 doesn't work. Okay, so as I'm working this out, I just realized in my head that this isn't factorable the way it's written. So we're going to go ahead and I'll change this in class. We're going to change this to a +10 here. All right, so that's going to change. Sorry, I will tell you guys in class to fix this. So we're going to have to make this a +10 because what I had written I don't think was factorable. So we're looking for factors of +20 because our reason still is the same because these multiply to 20x squared. But now we're looking for positive numbers that multiply to 20. So 1 and 20, 2 and 10, 4 and 5. So these work because their sum is +9. So before we were never going to get a sum of +9 with a -10 there. All right, so again, it doesn't matter where I put the 4x and where I put the 5x, but because of this 2 in my x squared, this is a little harder. So I've got to think where can I factor out the 2? Well, if I look in my top row, I can factor a 2 from this 4. So when I pull out my greatest common factor of the row, this time I'm including the 2. So I have a 2x. And then I know if I pull out a 2x there, I have to have an x here. So if I think, what would I multiply 2x to make 4x? Well, I would need this to be a 2 here. And then if I look at this column, since I've already pulled out or factored out an x, I need a 5 down here. So now when I check, 5 times 2 is 10, and it checks out. So our answer in factored form is 2x plus 5 times x plus 2. All right, so that is our answer in factored form. I'll make a note for us to change number 12 in class. All right, let's look at, I'm going to skip around. I'm going to have you guys try 13 and 14 on your own. Again, if you can divide a 3 out of all the numbers, you would want to do that first. And I believe 84 is divisible by 3. It's going to make it so much easier. Let's look at number 15. I thought this one might be tough because of the negative. So I'm going to say as a general rule, if we have a -1 in front of x squared, let's factor that out first. So if I divide everything here by -1 and write that in parentheses, that's just going to change the sign. So I'm going to have a positive x squared, a -8x, and a positive 12 here. All right, so I can't forget about the -1, but I'm going to factor just this part that after we pulled out our, in this case, GCF, I suppose, of -1. All right, so if we have, I'm going to write this as a positive x squared and a positive 12. So we have, we're looking for two numbers that multiply to positive 12x squared, but their sum has to be -8. So for two numbers to have a positive product and a negative sum, their signs must both be negative. All right, so if I think of things that multiply to 12, so factors of 12, I have -1 and -12, -2 and -6, -3 and -4, but only the -2 and the -6 will work for us because they have a sum of -8. So -2x, -6x. All right, so again, when we find our GCF, I'm going to pull out an x from this column, which means I must have an x here, so that x times x is x squared. Since we already pulled out an x from the column, we have to have a -6 down here, so that -6 times x is -6x. I've got from my row now, since I've already factored out this x, I need a -2 here, and then I should check that -2 times -6 is in fact positive 12. And it checks out. So don't forget about that -1 that we started with. So now in factored form, it's like we have a negative out front, the -1, and then we're left with x minus 2 times x minus 6. All right, lastly, in number 16, again, I want to check, is 5 a common factor of 16 and 12? And it's not. 16 and 12 are not divisible by 5. So again, that makes this a little bit harder. I'm going to draw a rectangle. The nice thing is these are all positives at least. So I have a 5x squared and a 12. And so when I multiply 12 times 5, I get 60. So I'm looking for things that multiply to 60x squared and have a sum of 16 or 16x. So let's think about our factors of 60. And again, if you need a calculator to help you, that's okay. Just grab one. Doesn't have to be graphing. You could use your phone if you're doing this at home. All right, so factors of 60. Well, I have 1 and 60. I have 2 and 30. Let's see, I have 3 and 20, 4 and 15, 6 and 10. Oh, and I forgot 5 and 12. But you know what? I think 6 and 10 are the numbers we want because, again, 6 plus 10 makes 16. So we've got to have factors of A times C and a sum of B. All right, so that means that I have a 6x and a 10x, and it doesn't matter where I put them as long as I put them in the two diagonal positions. And again, I want to check that does multiply to 60x squared. 6 plus 10 is 16, so we're in business. So now when it comes to factoring, I asked myself, what is the GCF? I'm going to go this way. What's the GCF of this top row? Well, I cannot pull out a 5 because 6 isn't divisible by 5. So I can only pull out an x from that top row, which means that this has to be 5x up here. So if I factored out an x from the top row, I hit the screen. I'd be left with a plus 6 here, so that 6 times x is 6x. So now going down the column, if I look at this column, well, 5x is the GCF of 5x squared and 10x. So we already did the top part, but if I divide a 5x out of 10x, I'm left with just the number 2. So I should double check that 2 times 6 is 12, and that works out. So again, our answer in factored form is going to be 5x plus 6 times x plus 2, because those are the dimensions of our rectangle.